This problem is asking us to find the maximum height of the ball. If the ball is modeled, its position is modeled by f of t, or y, is what they have, is equal to negative 16 t squared plus 48 t. The reason I write it that way is because I'm going to use the opposite of b over 2a to find the vertex. When I want the maximum, it's another way of saying what's the vertex. Um, just the way I've got this written out, this is going to be using t, that's the time axis. This is going to be the height axis, um, which is f of t, okay, or it's the height at time t. So basically what's going to happen here is you're going to have a parabola like that, and they're looking for that y value, or f of t value. The opposite of b over 2a is actually going to give you that t value, which is usually the x value that we're interested in, because the variables we're using is t. So t is opposite of b over 2a. So we're going to go opposite of b is negative 48. Over 2a would be negative 32. That's going to reduce to 3 halves. So that's the time here that we reach our maximum height. Now to find the maximum height, we take that t and plug it into the function f. So I take f of 3 halves gives me negative 16, 3 halves squared, plus then 48 times 3 halves. If I evaluate that all out, I get 36. So at time of 1.5 seconds, or 3 halves, I get a height of 36 feet. And that's what they're looking for. This question is very similar, except for now this is a displacement type question instead of a position question, but it's really all the same procedure. F of x is equal to negative 32 over 400, x squared plus x plus 6. I'm not sure why they write 20 squared there instead of 400. We're going to go ahead and use x is equal to the opposite of b over 2a now. Okay, so they want to know, it says find the maximum height of the ball. Well, it's going to happen at some distance away from the player, probably obviously halfway in between, or along that line of symmetry of that parabola, but that line of symmetry occurs at opposite of b over 2a. So we're going to go negative 1 over 2 times negative 32 over 400. So that's going to give me, that's going to cancel, gives me 200. Negative, negative makes it positive, flip, so it gives me x to equal 200 over 32. That's going to be, I think that's like 6.25, if you want to change it to a decimal. So now we want to know that's when it occurs. That's the distance the ball has traveled horizontally, and at 6.25 feet, it has then reached its maximum height. So we've got to plug that back in to find that maximum height. So negative 32 over 400, we have 6.25 squared, plus then 6.25, plus then 6, and that will all equate out to be 9.125. So at that point right there, the horizontal distance the ball has traveled would be 6.25, and the height that the ball has traveled would be 9.125. Now it has to find the horizontal distance the ball has traveled when it hits the ground. Well, when it hits the ground is another way of saying the y value is 0, so that means x-intercept. So when we're taking negative 32 over 400, x squared plus x plus 6 as our function, if I want to find the x-intercepts, I use the opposite of b, plus or minus b squared, which is 1, minus 4a, which is negative 32 over 400, times c, which is 6, all over then 2a, which would be negative 32 over 400. Okay. Now I'm going to leave that up to you to kind of evaluate and finish off. I think we should all be able to do that. But that's going to give me the x values in which the ball is on the ground. Okay. Now the equation, the function, does not know that there's a baseball player here and all that kind of stuff. So there are going to be two answers here, that one there and that one there. Okay. We're talking about the distance the ball has traveled when it hits the ground. So this number over here would actually be because the y-axis is basically going to be through this guy. The x-axis is here. This is going to be a negative result. It's one of these because there's two answers here. One of them is going to be negative. We get rid of that one. That one there we keep as positive, and we see it's going to be about a 16.9 as we do that. These piecewise functions have always been something that we've struggled with. What you're going to want to do here is graph these for these values. So if x is less than or equal to 0, we're going to graph negative x. Okay. So when it's less than or equal to 0, so I'm going to try 0. Should be 0. When it's negative 1, I should be at 1. When it's negative 2, I should be at 2. So I'm getting that. It's terrible. Getting that line, if I connect those, and I keep going that direction. Okay. Now between 0 and 3, I get 9 minus x squared. Well, between 0 and 3, so I'm going to try 0, and I get 9. So I'm going to go plot the point of 9. So let's say 9 is up here. And I would put an open dot. Okay. And now I'm going to go find 3. Okay, plug 3 in there, and I get 0. So let's say 3 is here, and I get 0. And then in between there is going to be the parabola. Okay, so that's 9 minus x squared then. And now x minus 3 for when x is greater than 3. So I'm going to try 3. I'll plug in here, I get 0, so it's going to be on top of that point there. And now I'm going to try something like 4. So 4 minus 3 would be 1. So 4 comma 1 needs to be plotted. And then keep doing that. 5 minus 3 would be 2, so 5 comma 2 needs to be plotted. And that keeps going on, greater than 3, so how do we get that? So that's my final graph for that piecewise function. Remember, you're going to graph it in pieces. So graph that first, okay, only for those x values. Then I'm going to graph this function, only for those values. Okay, and I think a lot of people, obviously, I think every one of us should be able to graph any one of these. It's just then realizing once I've graphed those, I only want the graph to exist for the x values of these numbers. So just be careful with that.